All right, thank you all for being patient there. It never fails. There's always technical glitches somewhere in a presentation. So I'm very pleased this morning to announce our second speakers here. Joining me here is Jason Carver and Daniel Ramirez, both with the Ethereum Foundation. And today they're going to be talking about replacing execution clients in staking setups.
Great. Thanks. So as you said, I'm Jason, also known as Carver online. I've been at the Ethereum Foundation for about 6 years, formerly working on Python tooling like PyEVM, and more recently on the Portal network and the Rust client for it called Trin. I'll get more into the Portal network later, and in a couple of minutes I'll hand the mic to Daniel, but we got a lot to cover, so we'll just get started. So we're looking at staking and the future of it without a full-weight execution client. So how are we going to address this question? So first we want to talk about what are we interested in aiming at, what's our ideal for what it would look like to have a lightweight staking system. And then we'll back up to where we are today, where Daniel will do the technical review of how the consensus client and the execution client talk to each other during staking. And then we'll come back to looking at active lines of research right now and how they each move lightweight staking forward and how they'll add up together to being able to get the full state execution client out of the picture. So let's look at lightweight staking. What does that mean? It can mean a lot of things, but obviously in general, we want it to be easy to stake. We want it to be easy to start, easy to administer the setup, and there's several impediments to that, but the one we're going to talk about today is disk space usage. So we would love to be measuring disk space usage in the 100 gigabyte or less range rather than the 1,000 gigabyte or more range. And the execution clients play a significant role in that, of course. And they are incredible pieces of machinery, and they're always getting better. But it's hard to imagine optimizing them to the point where they can hit these targets while still being a full client. So that takes us to the point of view of thinking, okay, well, it seems like we're going to have to seriously consider removing it from the staking setup altogether to hit this goal. So in order to really understand what that would look like, we have to kind of back up and see how our execution clients use during staking today. And so for that, I will hand it off to Daniel.
Yeah. Hi everyone, my name is Daniel. I have been contributing to multiple projects on the Ethereum ecosystem for the last year and a half, and now I'm part of the Ethereum Protocol Fellowship. So let's talk about how staking works today. Well, as all of you might know, running a validator node is something that uses a lot of resources. But why? Well, most of the blame can be attributed to the execution clients. Because if we do a quick comparison, we can see that the lightest execution client uses about 8 times as much disk space as the heaviest consensus client. And the same thing happens with other parameters like memory, bandwidth, and other things like that. But why does this happen? What does the execution client do that needs all of these resources? Well, it's mainly 3 things: starting up the node, building blocks, and validating blocks. So let's see how this works under the hood. Well, the 2 clients use the engine API to coordinate all these tasks. And I will be using these diagrams, sequence diagrams, to explain all of this. So just a quick introduction. The vertical line on the left is the consensus client, and the vertical line on the right is the execution client. The horizontal lines just indicate the API calls or the messages that they send to each other to communicate. So with starting the node, the first thing that happens is that they do a handshake. They exchange what engine API methods are available on each one of them. And after that, the consensus client calls fork choice update, which basically tells the execution client, this is the latest data I have on the fork choice, update your fork choice. And the execution client will verify that data and update its fork choice if it's correct. Now with block building, the consensus client is assigned to propose a block, and calls fork choice updated, but this time with a second parameter called payload attributes. This indicates the execution client to update its fork choice, but to also start building an execution payload. And after some time, the consensus client will retrieve this payload, calling get payload. And finally, block validation. For validating a block, the consensus client receives a beacon block. It extracts its execution payload and sends it to the execution layer to get verified by using the method new payload. I wrote an article explaining all of this in more depth. This is the QR code to it if you're interested in learning more about the engine API. But yeah, what does all of this mean? Well, it means that to run a validator node, you need one client that is able to respond to 3 endpoints: new payload, fork choice updated, and exchange capabilities. And what do we need to be able to respond to those endpoints? Well, we need a mechanism to validate blocks, a mechanism to build blocks, and access to the chain data. And well, how can we do that on a lightweight manner? We can't right now. The only way to serve those endpoints is by being a full-weight, heavy execution layer client. But there is some research being done right now by researching how we can solve this, and Jason will tell you all about that.
Okay, so what are we going to do about this? Where do we go? So a quick recap of some of the main challenges we have here is we're going to need to validate blocks from peers. We're going to need to propose new blocks. And perhaps outside of the staking scenario, we're going to want to look at the chain state, sometimes within it. So we'll do a little bit of a spoiler here about some of these technologies. So Veral, proposer builder separation, and Portal are going to help us address these things. So let's look at how that's going to be possible. First, I'll say that Portal is where I've spent my time in the last year or two. That's where most of my expertise is in. But Veral and PBS are core and critical components for this plan. So I'm going to do the uncomfortable thing and talk about them anyway, despite not being an expert in them. And I have a little bit of an ulterior motive here, which is if there are experts in them out there watching this, and I say something about the future of how they fit into lightweight staking that you disagree with, then at me. Let's figure it out together. So let's look at validating peer blocks. Now, just to confirm, this is not an optional thing. We can't just skip this step, because if we skip this step, then proposers can make arbitrary state changes on the network, and they become canonical. We absolutely must validate blocks coming in from peers. So traditionally, the way we're doing this is we get the block from the peer, we execute the transactions in that block against the chain state, and then compare the final state root against the block committed to by the peer. And to do that, we need the full client. Unless we include the state access during that block along with the block itself as it's passed around peers. And by doing that, in theory, we can have a stateless client that reads the state out of the bundle with the block while executing the transactions in it. And technically, it is possible to do that even with Merkle-Patricia trees today. The challenge is that they're too big. Well, they're not always too big. In fact, often they would be just fine. But it is possible for an adversary to construct a block in a way that would make them much too large and would drag the network to a halt. So it's a non-starter to include with the current tree structure. And that is one of the key benefits behind moving to Veral. So Veral is a tree structure that will allow us to create the state witness, which is just another way of saying the list of state that was accessed during the block and the proof that that state belongs to the canonical chain. So Veral allows us to create the state witness that's small enough, reliably small enough, to bundle with the block being passed around to peers. And so in this future, the stateless client can execute those blocks without keeping any state data locally. And I'm going to plant this thought here. We won't go deep into it this moment, but when you rip the state out of a client and make it stateless, it can now only do this one thing, which is verify the transactions in a block that have an attached state witness. So with Veral, we can address validating peer blocks, but that doesn't help us propose new blocks yet. So let's look at proposing new blocks, which is the process of looking at the transaction pool and including them. It's your slot, you're the proposer. You've got to look at the transaction pool, throw them into your block, order them for fees, and this is obviously going to require state access. And really, there's no way around this. So it kind of seems like we're stuck until the moment that we realize that we can separate the roles. So you can be a proposer and then ask someone else to build the block for you. And that is the essence of proposer-builder separation. So it's your slot. You say, hey, builder, make a block for me. And in a post-Veral world, you act in many ways like a validator of that block as if you were getting it from a peer. You still have to make sure that that block follows the state transition rules. But that block will include the state witness. The block from the builder will include the state witness. And so you as the proposer can validate it and then start passing it around to your peers. Now, MEV Boost is kind of an informal proposer-builder separation that's available today, of course. So why even include this? It seems like we're kind of already there. And the answer is that we want lightweight staking to be something that we as a community are happy about if every staker is doing this, right? And there are reasons to think that we might not be happy as a community if 100% of stakers were using MEV Boost in today's iteration. There are some open questions. There's reasons why we want to formalize it more broadly into proposer-builder separation mechanism. So for example, the story for transaction censorship is a little bit weak in MEV Boost right now. But we're a lot of the way there, and there's some great work happening on formalizing this. So we're kind of there. Maybe we're done. We've validated the blocks. We're proposing new blocks, and really those are these core features, these core needs of a staker. But I want to come back to this question of what is the stateless client capable of, and as I mentioned before, basically nothing. It's useless. It's useless. If you want to do things like look up your own validator balance, you can't do that on a stateless client. You can't do anything with it besides validation of blocks. And so there are lots of things that we might want to do, like submitting transactions for withdrawals, monitoring the deposit queue. There's even reasons to think that we might, if say proposer-builder separation is in a sort of offline mode, you might want to at least build an empty block, and you would still need some state to do that in order to create the new state root. And so there are reasons why we might want access to some state on demand. So if you take a stateless client and you add in the concept of on-demand state, then you get what I'm going to call a just-in-time state client. So this JIT state client is something that is an important piece of the puzzle for how do we get towards this lightweight staking. And our answer for that is the portal network. So let's look at the portal network and how that can help us get to JIT state clients. So Portal is a network that was specifically designed for the idea of on-demand selective access to state in a way that's verifiable against the canonical chain. So you can join this peer-to-peer network, and you store some small sliver of the chain. And for any pieces that you don't have, you just go find the peer that does have it and download it, that you have enough information between what the peer gives you and you already have. Those together are enough to validate this data against real chain information. So when we take that on-demand state access and we pair it together with a stateless client, right? We can stand on the shoulders of the stateless client teams here, and we can get block verification. Now we're on our way towards a JIT state client, or really we're there. It's worth noting here that, of course, to get state on demand will necessarily have higher latency. We're never going to be as fast at finding peers who have state and downloading it from them as we would to load it in a single shot from a local SSD. But if that means reducing our disk storage needs from a terabyte to a couple gigabytes, we figure that's a trade-off that a lot of people would be happy to make, especially when you're not in the middle of, say, proposing your block. We're talking about using this on-demand state access for sort of non-critical path moments. So how do we get to this JIT state client? It's useful to look at how, at this on sort of two axes. And there's on-demand state, which I've just talked about with Portal. And then there's, of course, the execution clients that have already been built. And the idea is that if we take Portal, which gives us on-demand state as we're heading towards it now. This is, by the way, Portal is in sort of an alpha situation. You can look at it and check it out, but it's probably only ready for you if you're happy browsing GitHub repos. It will be ready for more people soon. So we take the Portal client and we add in the stateless client. We embed a stateless client, and we've got a JIT state client. And that stateless client is a relatively straightforward thing to pull out of existing execution clients. They just can kind of rip out all the local state storage and learn how to read the state witness that's embedded with the block. But the question is, these execution clients might want to make JIT state clients themselves. And the question is, how do they get there? Well, from the stateless client to a JIT state client is sort of an unknown path. There's a lot of challenging questions that, of course, we've looked at from the Portal network, and we've been able to design our clients around those needs from the beginning. And it's not clear that, say, taking the existing execution client network and adding some features will help get them to on-demand state access. So, if they want to build their own solution, they can. And, we'll race them there to the JIT state client. It'll be fun. But, of course, they do have the other option of just joining the Portal network, right? So they can either import a Portal client into their own execution client, or they can implement their own version of a Portal client using the public specs from the Portal network. And we, of course, welcome that. And if there are any client teams out there listening that are interested in this, please reach out, and we'll be happy to help. So with that, with a JIT state client, Veral, and the proposer-builder separation, we'll be well on our way towards a lightweight staking future. So that's it for now, and I think we have maybe a minute for questions. Great, thank you.
Yeah, we do. Are there any questions from the audience? So perfect.
Thank you very much. Not that I really understood most of the detail that you were presenting, but just a very general question. As a staking operator, is it something that you expect everyone to move to save costs and to be more efficient when providing the services, or is it something that only specific operators will adopt in the future?
Yeah, we think there will be a lot of incentives to move for most stakers to move this direction. The big downside is if you do need close to instant random state access for some reason, or if it's important to you to be your own block builder, those would be two reasons why you wouldn't move this direction.
Any other questions from the audience here?
Yep. So right now the consensus layer is pretty sensitive to latencies. Like how could this impact like the performance of a validator running on a stateless client, based that now like the latency is getting even shorter? Like we're talking about not 12 seconds to propose a block and send it, but 4. Like, how does it impact?
Right. So the higher latency that I mentioned before about sort of on-demand state access often would sort of make it impossible to do your staking duties. That's why it's important that everything that you do as the staker in your slot or at verifying blocks, all of that has to be done statelessly. So that's why Vercal's a hard requirement for this path. We can't introduce latency there without causing problems. So yeah, I think you have the right idea.
Excellent. Well, Jason, Danielle, thank you very much for an excellent presentation.
Yeah, thanks. Thank you.